Okay, good morning students. So we were discussing about the salts, that is acidic salt, basic salt, neutral salts, etc. So I think some of you didn't understand what is how it is formed and how which one is acidic salt, which one is basic salt, and how by the name itself or from that name, from the molecular formula, can we find out whether it is acidic or basic. So that those things, some more explanation I will give you now. That is, for example, and in your textbook, that is page number 29, I think 29, yes, 28 and 29, that is activity 213 and 214. 213 and 214. This activity you can do by yourself. Okay, I will explain now how can we identify which one is acidic salt, which one is basic salt, etc. And the pH of these salts, based on the pH of this salt, we can also assess that, because if it is formed between strong acid and weak base, it will be an acidic salt and its pH value will be less than 7. And if it is formed between strong base and weak acid, that resultant salt will be basic in nature and its pH value will be greater than 7. So let me I will tell you some examples. For example, ammonium carbonate, NH4 twice CO3. You should know the formula, how to write the formula. Ammonium carbonate, this is the formula of ammonium carbonate. So this is the salt. So here this is the salt, the name of the salt, and we can also write the parent acid, or from which acid it is formed, and this next one is parent base, parent acid. So ammonium carbonate, okay, I will just 1 minute. We know there are two components in a salt. One is this is the basic radical, and this is the acidic radical. We know that why it is called the acidic radical and why it is called basic radical, because cations are formed from the bases and anions are formed from acids, isn't it? That is why it is called the acidic radical and basic radical. And here ammonium ion, actually NH4 plus ion. So this is the basic radical, this is the acidic radical. NH4 plus ion, this is the basic radical, and which is the base that is related to ammonium, that is its hydroxide. So ammonium hydroxide, NH4OH. So that is the parent base, ammonium hydroxide. Ammonium hydroxide is the parent base of this ammonium carbonate. And carbonate, this is acid. For which is the acid that is related to carbonate, or the formulas of different acids. Carbonate, that is carbonic acid. Carbonic acid. What is the formula of carbonic acid? H2CO3. So from this H2CO3, carbonate ion is formed. So the parent acid is carbonic acid, parent base is what? Ammonium hydroxide. So we know here this carbonic acid, it is a weak acid. And ammonium hydroxide, it is also a weak base. So, weak acid and weak base they form, they also forms what? Neutral salt. So, ammonium carbonate is a neutral salt. It is a neutral salt. Weak acid and weak base they form neutral salt. Then take another example. So, ammonium carbonate is a neutral salt because it is formed from a weak acid and weak base. And another example, you take any example. I will in your textbook take sodium nitrate. Okay, sodium nitrate. What is the formula of sodium nitrate? NaNO3. Sodium nitrate. NaNO3. So we know this is the NaNO3. NaNO3. So this is what? This is the acidic radical and this is the basic radical. So which is the acid that is related to nitrate NO3? So NO3 nitrate. We know the formula of nitric acid. What is the formula of nitric acid? HNO3, isn't it? So nitric acid is the parent acid. And Na, the hydroxide of sodium, that is, what is that? Sodium hydroxide, NaOH. So this is the parent acid and this is the parent base. When these are combined, we get sodium nitrate plus water. So here nitric acid is a strong acid, sodium hydroxide is a strong base. So strong acid and strong base they form what? Neutral salt. So sodium nitrate is also a neutral salt. Then take another example, copper sulfate. See, CuSO4. Copper sulfate, the formula of copper sulfate is CuSO4. And you know, sulfate, here the acidic radical is sulfate. So sulfate is derived from the acid. Which acid? That is sulfuric acid, that is H2SO4. Sulfate is derived from sulfuric acid. And copper, what is the base corresponding to this copper? That is copper hydroxide, isn't it? Copper hydroxide, CuOH twice. So copper hydroxide and sulfuric acid, it forms copper sulfate. So here what is sulfuric acid? Sulfuric acid is a strong acid. It is a strong acid. And what about copper hydroxide? Copper hydroxide is a weak base. It is a weak base. So strong acid and weak base, we get what? This is acidic salt, because since the acid is strong, so it is acidic salt. This is acidic salt. So the pH value of this solution will be less than 7. It will be less than 7. In these two cases, it is equal to 7. It is approximately equal to 7. But here it will be less than 7. Why? Because it is formed between a strong acid and a weak base. Now take another example. A salt formed between strong base and a weak weak acid. Strong base and a weak acid. One example. Strong base, that is take a weak acid. Weak acid is acetic acid. We can take weak acid. Weak acid is acetic acid, and strong base NaOH. Okay, take this example. So we get we are taking CH3COO CH3COO, that is called sodium acetate. Sodium acetate. So, which is the acid? Which is the acid that is present in the salt? So, from which acid is formed? That is CH3COO, that is acetic acid, you know, CH3COOH, that is called acetic acid. This is the parent acid. And sodium, the corresponding hydroxide of sodium, that is NaOH. So here it is a weak acid, this is weak and this is strong. So weak acid and strong base, it forms what? It forms a basic salt and its pH value will be greater than 7. Here it is less than 7, and for these two it is approximately equal to 7 or nearly 7. So it is these two are neutral bases, neutral salts. So this is weak acid, weak base. So I hope you understood all this. What is a neutral salt, what is a basic salt, what is a acidic salt, isn't it? So these are about types of salt. Okay. So that activity number 213 and 214 you can do. You can write in your notebook which is the parent acid and which is the parent base, and from this you can also write, because in that it is written, it is also written that which is the acidic radical and basic radical. Acidic radical and basic radical. Here acidic radical, in this case which is the acidic radical? Acidic radical is CO3 2 minus, CO3 2 minus, that is the acidic radical, and ammonium ion, that is the basic radical, NH4 plus. You should know the charges, their valencies, their charges, no, that you have studied in 9th standard, no. And here NaNO3, which is the acidic radical, NaNO3, NO3 minus ion, that is the NO3 minus, not 2 minus, NO3 minus, and Na plus is the basic radical. And here copper sulfate. So acidic radical is SO4 2 minus, SO4 2 minus, and Cu 2 plus. You know how this charge is coming, Cu2 plus 2 minus, you know. Here it is NH4 plus, but here there are 2 NH4. So that is why twice CO3 2 minus, one CO3 carbonate ion carrying minus 2 charge. That is why minus 2, in order to neutralize minus 2, there should be 2 positive ions. That is why NH4 twice, NH4 plus. Okay. And here CH3COONA, in this acidic radical is what? CH3COO minus is the acidic radical, and Na plus is the basic radical. So that activity 213 to 14 you can write in your textbook, in your notebook. Okay. Okay. So if you have any doubts regarding these topics, you can ask to me personally, no problem, that you can ask, or in a group, no problem. So we move on to the next, that is some important salts, that we are going to discuss about some important salts. Some important salts. First one is common salt. Common salt, otherwise known as, the formula is NaCl, common salt. We know this common salt, it is an important, we are using in our daily life. NaCl is an unavoidable substance, sodium chloride. And this sodium chloride, we know it is a white crystalline substance. Its chemical formula is sodium chloride. And then how this sodium chloride is prepared? In laboratory, sodium chloride is prepared by the reaction between sodium hydroxide, aqueous solution of sodium hydroxide plus HCl, hydrochloric acid and sodium hydroxide, we get NaCl plus H2O. So, this is the laboratory preparation of sodium chloride. Sodium hydroxide react with the hydrochloric acid, we get sodium chloride plus H2O. Now, next is where the source of this salt. This is the laboratory. In laboratory, we can prepare sodium chloride by this process. And let us see what is the source of this salt. Source of salt, common salt. It is also called a table salt, no? Okay. So, this source of salt, the main source of, we know that the main source of sodium chloride is sea water. We know the sea water contains many kinds of salt, but majority or the maximum percentage of salt is sodium chloride salt, that is common salt. It's a solution, it's a mixture of common salt. It also contains many other salts, but the highest percentage is what? Common salt. And we know these sea water, it is trapped in a shallow tank or shallow pits, and then it will be evaporated by the use of what under the sun, and also by the use of wind it will evaporate. So, after evaporation we get the salt crystals of sodium chloride, and it can be purified later. So, that is the one salt. Another one is, the other source of sodium chloride is rock salt. Rock salt. You know, rock salt is found in different parts of the world, and this is somewhat it is often they look it is brown color. Why? Because it contains many impurities. That is why. So, it is dispersed in different parts of the world, and it is having brown color because of impurities present in that. So, these two are the main source of sodium chloride. Now, this sodium chloride, you know, what is the use of this sodium chloride? Sodium chloride is used in it is an important component of food. That is the first one. It is an important component of food. It is used in in preservatives, just like you know, in pickles we are using this salt. We are adding salt. So, it is an important component of food. It is used in preservatives, and it is used for this one freezers, freezing purpose it is using. We are using for freezing purpose. Sodium chloride will it reduces the freezing point of ice. That is why we are using in freezing mixtures. In freezing mixtures we are using sodium chloride, and then it is used in the preparation of many substances, like in the manufacture of large scale manufacture of chlorine, large scale manufacture of hydrogen and hydrogen chloride, washing soda, soda lime, etc. In all these cases sodium chloride is using in the manufacture of large scale manufacture of hydrogen, chlorine, hydrogen chloride, and then soda lime and washing soda, etc. In all these cases we are using sodium chloride. So, these are about the common salt. This is the laboratory preparation of common salt. Now, we are discussing the different other compounds which are prepared from this sodium chloride. Important salts which are prepared from which are derived from sodium chloride. Okay. First one is sodium hydroxide. Sodium hydroxide formula NaOH. It is also called as soda lime. It is also called soda lime. So, this sodium hydroxide, we know sodium hydroxide is commonly known as caustic soda. Sodium hydroxide is commonly known as caustic soda. Caustic means it causes burn, even it burn our skin. So, it is caustic soda. It is highly corrosive in nature. It is highly corrosive in nature, and this caustic soda is prepared by the process of chlor-alkali process. Chlor-alkali process. It is prepared by the process that is called a chlor-alkali process. So, chlor-alkali process, it is what is chlor-alkali process? It is the electrolysis of brine. Electrolysis of brine. What is brine? Brine means aqueous solution of what? NaCl, sodium chloride. That is called a brine. So, electrolysis of brine, we get what? We can prepare sodium hydroxide. So, during electrolysis of brine, chlorine is formed in the anode. Chlorine is formed in the anode, and hydrogen is produced in the cathode along with the sodium hydroxide. So, that is this is called a brine solution. Brine, brine, that is NaCl plus H2O. Electrolysis of brine, we get sodium hydroxide plus H2 plus Cl2. See, this is called a brine solution. These two are called a brine, that is aqueous solution of sodium chloride is called a brine. So, brine on electrolysis we get sodium hydroxide plus H2 plus Cl2. Cl2 is formed in anode, that is chlorine is formed in anode, and hydrogen is formed in cathode, and also we get sodium hydroxide. Since the product is contain chlorine and alkali, I told you that alkali, there are certain bases. The base which are soluble in water, they are called alkali. All bases are not alkalis, but all alkalis are bases. Okay, all bases are not alkali. Alkali means they are water soluble. They are soluble in water. So, the bases which are soluble in water, they are called alkali. This sodium hydroxide is also an alkali because it is soluble in water, highly soluble in water. Since in this process we get chlorine and sodium hydroxide. That is why it is called chlor-alkali process. Chlor-alkali. Chlor for chlorine and alkali for sodium hydroxide. So, that is why it is called a chlor-alkali process. So, on a large scale we can prepare sodium hydroxide by chlor-alkali process. Okay, this is about sodium hydroxide. Now, what is the properties of this sodium hydroxide? This is the preparation. Now, the properties of sodium hydroxide, we know Sodium hydroxide, I told you in the beginning that it is highly corrosive in nature. It is highly corrosive in nature. You know, it may cause burn, just like acid, strong acids. When we pour some acid on your skin, you know, it will burn. The same kind of experience will be there if you pour a strong solution of sodium hydroxide. Sodium hydroxide is highly corrosive in nature, and it is highly water soluble. Sodium hydroxide is highly water soluble, and this sodium hydroxide can conduct electricity in the aqueous state as well as in the molten state. In the molten state, when it is melted, in the molten state, it conduct electricity. In aqueous state also it conduct electricity. So these are the properties of sodium hydroxide. And this sodium hydroxide, what are the use of sodium hydroxide? So properties I told you, it is highly corrosive in nature, it is highly water soluble, and it conduct electricity in the aqueous state as well as in the molten state. Now the uses of sodium hydroxide. Sodium hydroxide is it is used for the manufacture of soap and detergents. In the manufacture of soaps and detergents. Soaps and detergents. And soaps are sodium or potassium salts of higher fatty acids. So that you will study later, because in this I think in the upcoming chapters we will study about the soaps, the action of soaps, etc. So soaps, sodium hydroxide is used in the manufacture manufacture of soaps and detergents, and this sodium hydroxide, it is used for another use of sodium hydroxide is that it is used in textile industry and paper industry. Textile industry and paper industry. Then it is also used in paper industry, and this sodium hydroxide is also used in the refining of bauxite. It is also used in the refining of bauxite. This bauxite, what is bauxite? Bauxite is the ore of aluminum, isn't it? It is an ore of aluminum. So in all these cases, sodium hydroxide is used. It is also used in the preparation of hydrochloric acid. It is also used in the preparation of, so fifth one you can write, in the manufacture of hydrochloric acid. So these are the different use of sodium hydroxide. So hope you understood now all these things. Now we were discussing about the different salts, and then some important salts. That salts is prepared from common salt, and first one we discussed, that is sodium hydroxide. So the next salt that we will discuss in the next class. Okay, have a nice day.